This is Origin Stories, the Leakey Foundation podcast. I'm Meredith Johnson. In today's bonus episode, there's more to explore at Boomplaas Cave in South Africa. In our last episode, Field School Diaries, we took you on an immersive and emotional journey through the field school experience. Today, we're digging deeper into the scientific research they do at Boomplaas Cave to learn what makes it such an important and interesting place to learn about evolution, climate change, and human adaptability. So Origin Stories producer Ray Peng interviewed Leakey Foundation grantee, Baldwin Fellow, NYU professor, and field school director, Professor Justin Pargeter. Here's Ray.
First off, thanks so much for recording like dozens of hours of field tape. It's a real treat to have gotten such intimate recordings from you and your students. We haven't done that before at Origin Stories, so this is kind of a first for us as well.
You're welcome. Yeah, it was quite a new experience and it took a lot of getting used to, but it, I think, allowed all of us to get a sense of where we were as a team. And there were a lot of conversations that followed from those check-ins that gave us insight on who we are as people, who we are as scientists, who we are as a community. So what we hope that students get out of it is a view of archaeology as an international science, that it's not nationalistic, right? It's not about what country you come from or what your background is. It's about your question and your approach. And the idea is that they leave and they can go and start their own field sites.
You brought up the point that archaeology, at its best, it shouldn't be like a nationalistic pursuit, but so many countries have used it as such.
Yeah, it's we have a legacy in our field um, that has traditionally excluded communities from participating in science at the top levels. And that's a legacy that we have to confront and deal with in our science. We can no longer ignore it or work around it. And I think, the ability to tackle some of the big problems in archaeology and paleosciences across disciplinary boundaries and across cultural divides is foundational to where archaeology needs to go as a science, and to developing problem-solving capabilities and capacities that foster a global society of scientific inquiry into the past. Having African scientists lead research sites, I think, is critically important, because these projects have the potential to make more significant impacts on local scientific capacity within the countries that they're being conducted in, and to generate a new kind of research output, right, that reflects the true range of participants in the kind of work that we do. We also need to sort of promote the idea that thinking about science is a diverse activity, right? It's not a set formula. There are things that can be done better in terms of how we do science, but thinking about it needs diversity and diverse perspectives. So I think that, we have a lot to do to overcome the historical legacies, particularly in South Africa, where the history of the country is one where, archaeologists were actually at the forefront of fighting against the apartheid state and trying to come up with solutions that would be more inclusive. But at the same time, we've ended up with a legacy where the field is dominated by certain demographics, and we've got a lot of work to do to change that. And the scientific capacity of the country is incredible. We have huge resources, both in terms of our people, in terms of our labs.
Circling back to the field site and the research itself, what were your guiding questions at Boomplaas? And am I saying that correctly?
Yeah, it's Boomplaas. It basically means the tree farm. So, that context for the name of the farm actually informs some of the research that we're doing at the site, which is to understand how did ancient climates and environmental change at multiple scales across the landscape impact human occupation at the cave. So we're interested in finding out whether climate and environmental change more broadly across wider landscapes relative to the kinds of shifts that we might find near to the sites within the local valley, which one of those, or perhaps both of them in what configuration, is an important predictor of human behavior at the site itself.
That's so cool. um, so in your recordings, you stated that this cave is a legacy site. What makes this cave a legacy site?
Yeah. So Boomplaas Cave is a legacy site largely because we can consider it a key sequence for understanding human evolution within this particular region of South Africa. The site was first excavated by the late Hilary Deacon between 1974 and 1979, at a time when Paleolithic archaeology in South Africa had many decades of work done, but we were still kind of at a pioneering phase of how to actually conduct multidisciplinary field research to a high international standard. And Hillary's excavation set that standard for the use of many different kinds of scientific methods to understand ancient human environment interactions. And Hillary tried to ask a different kind of question at Boomplaas to those that were being asked at many other Paleolithic sites in Africa at the time. So Hillary's questions were very much about linking human and biotic factors together into a research agenda. The site has one of the best preserved records for human evolution over the last 80,000 years, perhaps anywhere in Africa. And the site served as a training ground and a career stepping stone for several of our field's most prominent researchers. These are all people who really either pushed methods and developed them at the site or started their careers there. Judy Seeley, who is now one of the world's most prominent isotopic scientists and the director and established the isotopic lab at the University of Cape Town, which is now one of the best in the world, was going to be a doctor until she came to Boomplaas. And Hillary exposed her to an excavation process and a set of research questions that completely changed her world and got her basically to sign up for archaeology. And our field could not have been, better placed to make use of that. And the other important part of the work, the site itself, is that it sits adjacent to some of the most famous Paleolithic sites in South Africa. That is places like Pinnacle Point, Boomplaas Cave, Klassies River, all of which are on the coast. And Boomplaas is really the only site that's inland of these. It's about 80 kilometers from them. So it tells us what humans were doing when they were not at the coast. So it's a key legacy site for its location as well, and for what it can tell us about some of the other important cave sites in South Africa.
Wow, I didn't know all that, and I think for many of our listeners, this will be the first time that they're hearing about this site and this cave. Like, there's such a focus on new hominin fossils and the discovery of new species or the oldest this or the oldest that. But there's a very different response to archaeological stories that look at a collective versus an individual. This kind of like longitudinal site offers, in a way, so much more, but it's not always as celebrated outside of the group of specialists who are writing about it. It's kind of like inside baseball, to use an American reference. How do you translate the story of not just the cave but the research to the public?
Yeah, you're definitely correct that sort of the grunt work of Paleolithic archaeology tends not to be 90% of it not to be glamorous, right? I think to some degree we try and use platforms like this to really talk about the story of the site and the work we're trying to do to transform paleosciences. And again, sort of going back to this idea of like, who are we doing this for, and why does it matter to have Africa at the forefront of our work? South Africans have a deep appreciation for the ancient past, and it's a product of sort of nation building post-apartheid. Nelson Mandela and then Thabo Mbeki were both presidents who realized that the public religion that they wanted to build for a new South Africa, this idea of a shared set of values and ethos that needed to be built after apartheid afresh, really had to come from a kind of a common ancestry perspective, right? That we all share this land and a legacy in South Africa. And they turn to archaeology for that language, right? They turn to archaeology for that inspiration, such that I think we're one of the few countries on the planet that actually has rock paintings on our currency. And our coat of arms and our national motto are derived from Click languages, ancient, Click languages amongst, some of the last hunter-gatherers in Southern Africa. So South Africans, yes, they go for the sort of Naledis and like the big cradle of humankind stories, but they love the science of archaeology. Much more so than I think I've experienced amongst many other nations where I've lived, and so I think we've actually had a great amount of success about communicating the process, right? We have a comic book series that we've been building over the last few years with a media company in South Africa called Jive, that actually takes basic concepts in archaeology and communicates it to school-aged children across the country. That is like, how do we study charcoal, or how do we date archaeological sites, or what did ancient diets look like? And they're like 4-page comics with Black African characters in them, and they're translated into several languages. We just produced the third one last week, and they go out to about 120,000 school children once a year. And they don't try and glamorize the science beyond like what is actually really special about it, right? Which is reconstructing, using elementary science and cutting edge techniques, how we lived, right? How we evolved. And I think that's given the country a deeper appreciation for the process of archaeology, away from the sort of clickbait headline kind of stuff that tends to get most people sucked in, right? And then you end up reading the paper and you're like, oh, that actually didn't do what I thought it was gonna do, right? Oh, like this didn't actually revolutionize the science the way that I thought it would.
I think you're right in that so many people have an interest or an inclination towards the ancient past, and finding ways to like feed that interest and that enthusiasm that aren't just proof that X and Y equals Z. Like so much of the clickbait is like very like reductive in an insulting way.
Right. But no, I was also just thinking, I think it also breeds kind of the wrong thinking about archaeology as a science amongst the public. This idea that every discovery kind of overturns our understanding of human evolution really, I think, feeds into the idea that like archaeology is not an established science, right? That like if it can be overwritten or redirected with every new discovery, you're dealing with probably a fairly immature science that's still trying to establish its framework that was the case probably 100 or 200 years ago for many other sciences. But that's it's not actually the case, right? In fact, many new discoveries feed into long-held theories and hypotheses about human evolution and actually do support them or help refute them. And so I think there's a danger in that kind of clickbait science that undermines archaeology as a long-held discipline with theoretical frameworks that aren't easily overturned, right? If the science is done properly and done slowly and well. I mean, I think we face a sort of a crisis of science in some ways at the moment. This really does force us to come back and to teach some basic foundational principles about method and inquiry and question generation and hypothesis generation that can give the foundation to creating critical consumers of science and critical consumers of information. So I think it's even more critical now than ever before that we give students concrete scientific experiences, right, where they can generate information, they can test hypotheses, they can work through problems in hands-on settings, and that's exactly what we do at Boomplaas.
Okay. So, like, how does this site, like, does it change or complicate the ways that we understand how humans have related to their lived environments?
Yeah, in a big way. So, one of the things we have to understand about our research question and trying to address this issue of how ancient climate change and environmental change has impacted human evolution is that we have to match the scale of the questions with the scale of the data. What we're trying to do at Boomplaas is using the wealth of information from the site and in the region around it is to, as I said earlier, reconstruct climates and environments at multiple scales, ranging outwards from the cave. The hyperlocal scale comes from information that we get from things like charcoal that we find at the sites that it occurs in high abundances that we can use to reconstruct vegetations, microfauna, these tiny little rodents that get dropped in the cave by raptors and owls, isotopic analyses of the sediments and the bone and teeth that we find at the sites, pollen from the sediments, other kinds of biomarkers that tell us about the local environment. How much water is there? What is the temperature like? What is the vegetation cover like? And we contrast those patterns with records we get from the mountains and the caves further out from the sites. And we use things like that are called hyrax middens, which are in North America, we call them pack rat middens, but they're basically places where these cute little creatures called dassies or hyraxes, they go and defecate year after year in the same place, and they end up forming a long-term climate record in those middens. And what it is
From
basically
their poop?
the urine, yeah. So the
Okay.
urine solidifies and it essentially becomes like a glue that traps anything that's airborne in that environment in it. And that includes pollen, phytoliths, micro charcoal from landscape fires, wildfires, and we cut through them and we can actually analyze them like we do tree rings. They form on a high resolution scale, and we can analyze each one of those bands. We could do the same thing for things called speleothems, which are drip water formations that form inside of cave systems. And we can actually cut through those too and analyze those bands and date them and reconstruct ancient climate and environment at ultra-regional scales. So these speak to how water and temperature and vegetation change are distributed much further away from the sites. And by doing that, what we've actually found is, we're able to overturn some long-held wisdoms about the effects of climate at a planetary scale versus a regional scale. So, for example, the last glacial maximum, which is one of the coldest periods in our planet's climatic history, occurred between about 28 and 19 or 18,000 years ago, kind of the last big gasp of the last ice age before we enter into our current climatic phase. Used to be thought of as this like really terrible time for humans, and that's because most of Europe is covered in ice at this point. People entering into North America really get stuck in places like Thuringia and Siberia until those glaciers melt and move away. In Africa, what we're finding is that in fact at these local scales, rainfall was increasing, grasslands were expanding, and people had a pretty good time.
Can I interrupt for a second or ask
Sure.
what is the age range that you're looking at? Because you're talking about climate change over like a long period of time. And for myself and probably everybody in the world right now, when they hear climate change, we're talking about it within the span of 200 to 20 years.
Right.
And so, like, what age range are you looking at within this cave system and within this area?
Well, at the large scale, we're covering the period between roughly 50,000 years ago and 10,000 years ago. So this is the last part of the planet's last ice age. Yeah. So at the large scale, that gives us a view on variation across the last bit of the ice age. But within that, we're also focused on reconstructing seasonality, for example. So we have methods that allow us to determine the variance in rainfall and temperature seasonally within an annual cycle.
Wow.
So what we're trying to do here is marry these different scales of climate and environmental change. So our humans at the site during a certain part of the year, is that how they're scheduling their mobility and movement around this landscape? And does that shift, how does that shift over time? If certain seasons are targeted at some points in that sequence and other seasons at other points, and how does this feed into larger planetary climatic systems and changes?
So in your recordings, I think you said like 60 to 70% of the plants that you were finding had some medicinal use. How common is that at sites?
It's it's not very common. The Cape Floristic Kingdom, which is the general biozone that we're working in here, is one of the planet's major biodiversity hotspots. So what that means is that within a very small region, we have an extremely high level of biodiversity. And, you know, what we're coming to realize is that that biodiversity is not just in like generic plants and trees, but actually specifically around edible and medicinal plants. Now, that leads us to the hypothesis, like, would that kind of system have evolved independent of humans being there? So that is one of our big research questions that we're trying to answer with our modern botanical surveys in the area, as well as the plant record at Boomplaas, which is exceptional, is can we find some correlation between the density of those medicinal and edible plants and archaeological sites in the landscape? So in other words, do they occur at higher densities near places where humans have lived for really long periods of time?
So just so I understand, like, so the existing like flora around the cave, it has that high of a density of consumable plant materials.
Yeah.
Is that reflected in your kind of pollen and archaeological floral analysis as well? Can you see like a long existence of the plants going back to these times?
It's a study, we're busy working on this problem right now, and it takes a lot of time and a lot of different kinds of data. But what we're starting to see is that there definitely were certain kinds of edible and medicinal plants that are being brought back to the cave periodically through the sequence. So one of them is a particular kind of nut called Papia capensis. It's like a wild plum. And it has a fairly astringent fruit that doesn't, to us today, doesn't taste very great, but to ancient foragers would have been lovely in the absence of like high fructose corn syrup. These wild plants taste lovely. But the nut itself inside the fruit produces an oil that can be used as like a moisturizer, but also as to make fire and lamps and candles. Um, there's an and what we're doing right now is we essentially pass all of the excavated sediments through a flotation machine that allows us to pick up all the tiny little bits of plant remains throughout the excavation. And as we're doing this, we're realizing that this seed keeps on popping back up again and again and again over thousands of years at the site. So there is definitely a long-term consistency in certain plants, and they have definite uses. Another one of them is what's called a hoof ball. It's a poison ball, and we have evidence at the site that hunter-gatherers were digging storage pits into the cave and lining them with the skin of this bulb. And it's actually a poisonous bulb, so what it does is creates a protective environment for anything put inside of it, protects it from bugs and animals.
Bugs and vermin.
Exactly, and so they're putting these Papia capensis seeds inside these storage pits lined with this poisonous bulb as a form of delayed return, right? So it's something they could come back to in the future and eat. And we're finding again those poison bulb remains occur throughout the sequence, and sometimes in correlation with Papia capensis seeds. So this is only the tip of the iceberg, and we really are only now starting the work that will uncover this long sequence of plant knowledge at the site. But it's going to take a number of years to get there.
That's so fascinating. Traditionally, humans aren't credited with cultivating plants till what, like 10,000 years ago, approximately?
Roughly around there,
Ish.
yeah. A little earlier in some parts of the world, yeah.
Is this kind of like an early example of humans engineering their environment?
It's definitely along the lines that we're thinking, is that the Cape Floristic Kingdom's high medicinal and edible plant diversity is a product of humans distributing plants throughout this landscape in very specific ways, very patterned ways that increase their diversity and density around archaeological sites. So there's been a growing movement over the last decade or so to consider humans as long-term agents of environmental change, not just with the advent of agriculture, but actually into our deep hunter-gatherer past. So the other question that comes from this is fire. And have we been using fire in these landscapes over long periods of time to change the ecology and increase biodiversity? So today, the Cape Floristic Kingdom is a fire-dominated ecosystem. So it needs to burn periodically in order to regenerate. And a lot of the things that regenerate really well after fires in this region are things like underground storage organs, bulbs, and corms, which are like wild potatoes. And we have a method now in place to pick up evidence for these potatoes being cooked in the fireplaces at Boomplaas. And we've found it. So, one way to increase the density of these potatoes in these landscapes is to periodically and consistently fire them. So what we're going to do with the Hyrax middens that we get from the mountains around the cave is compare how much charcoal we can find in the air around the site at certain points in time to how dense the human occupations are in the cave. And that'll tell us whether or not fire frequencies in this landscape correlate with human occupation of the cave, and thereby answer that question of whether or not we're firing these landscapes. And such that today what we think of as a natural environment is actually completely the product of humans.
In your recordings, you mentioned that you were struggling to describe the change in the field site over time because of how incremental the work is and how incremental the scientific process is,
mm,
and like the kind of intense presence that is required to do the work. But you noted that the change that you did see took place in your teams. Can you elaborate on this some more?
a lot of students came into our field sites, and the field team, very shy, very in a bit of and a little bit worried about speaking out, or just the idea of making themselves heard. And that one aspect of change through the field season is definitely seeing a lot of people open up, come to terms with their roles in the team, become more confident in their positions. And I think you probably heard from a lot of the recordings, just become very wed to their jobs. They love their jobs at the end. They're very defensive of them, and They want them to be done properly. They develop a level of professionalism and commitment that I don't think any of them ever thought that they would coming into a field season.
Wow, that's really powerful. It seems like there's so much that people took away from this school and took away from the experience. Just kind of briefly, like, how did you end up leading a field school? Or, like, why did you want to lead a field school?
Well, so I think it was a natural growth out of the work I'd been doing at Boomplaas for my PhD. I had studied the collections from the sites in great detail, realized that we needed a lot more work to be done at the cave, and that in order to do this, we had to do a lot of work to fix up the site and get it up and running again. As an undergraduate, I had mentors that really encouraged us to get into the field and to participate in the research process. And that's something that I always wanted to carry forward in my work and to pay back. And Boomplaas is just the perfect site to do it at. So I think, all that together gave me this like toolkit that I could now say, hey, here's the perfect way to pay back the kind of training and experience that I received as an African scientist growing up in South Africa.
And lastly, what do you hope people take away from listening to these field school diaries?
I think what we have to offer to people listening is really a hope that the future of archaeology, the future of paleosciences is one in which global diverse voices are really important. And they're important because they allow us to change the kinds of research questions we ask, but also the way we do field work and the way that we imagine field work playing out for people.
Thank you so much. This has been really great.
No, thanks, Ray. And I really appreciate the Leakey Foundation providing the opportunity to voice, basic science and, the work that we're doing that, as we discussed earlier, isn't making necessarily huge headlines in newspapers and tabloids, but has the potential to transform the way that we study the human past. So very grateful for the opportunity.
Thanks again to Justin Pargeter and everyone at the Boomplaas Cave Field School who made these last 2 episodes possible. If you've made it this far and you haven't yet listened to Field School Diaries, please check it out. If you're a student interested in attending a field school like Boomplaas, you may be eligible for the Leakey Foundation's Joan Cogswell Donner Field School Scholarship. Follow the link in your show notes for more information. Origin Stories is a project of the Leakey Foundation, a nonprofit dedicated to funding human origins research and sharing discoveries. Support this show by going to leakeyfoundation.org/donate and making a donation of any amount. Origin Stories is audience supported and is made possible by listeners like you, with additional funding from the Anna Gordon Getty Foundation, Jeannie Newman, and the Joan and Arnold Travis Education Fund. This episode was produced by Ray Pang. Our editor is Audrey Quinn. Theme music by Henry Nagel. Additional music by Blue Dot Sessions and Lee Rosevear. Thanks for listening.